A blessed morning to everyone watching. We are STEM 11 Knowledge Kit 2 and 8, and in this video, we will be reflecting on everything that we have learned and experienced in Robotics 2. So, buckle up your seats and get some popcorn ready because this is about to get educational. Now, throughout this course, we worked with different robotics components such as servomotors, ultrasonic sensors, and I2C LCDs through multiple activities and tasks. This reflection will focus on our technical understanding of these components, how they work together as a system, and the challenges we faced, and the lessons we gained from the experience. So, without further ado, let's get into it.
Servomotor. What is a servomotor? At first, we thought a motor was just something that spins or whatever. Then we met the servomotor, and suddenly, angles mattered a lot. What I mean by angle is how it's designed to control movement with precision, specifically by rotating to specific angles instead of continuously spinning like a regular DC motor. Unlike DC motors that are simply on or off, servomotors allow controlled and accurate positioning, which changed how we viewed movement in machines, robotics.
The ultrasonic sensor looks like a mini radio, right? Who knew that it measures distance by emitting sound waves and calculating how long it takes for those waves to bounce back from an object? We certainly didn't. Now that we actually know what it is and what it does, let's move on to the things we've noticed in our activities regarding it, like how its readings were sometimes inconsistent, how it wouldn't even work for some reason, and how factors such as hand placement, the angle of the object and distance affects the accuracy of the sensor greatly. Even so, the ultrasonic sensor made the system feel automated. Seeing real-time distance values displayed in the Arduino serial monitor helped us understand how sensors allow systems to react to their environment. This showed us how similar technologies are used in real life, such as the sensors in vehicles that alert drivers when they are a tad too close to an obstacle, saving them from crashing or hitting their car. Very useful indeed, right?
The I2C LCD. Looking at it, it wasn't the most exciting component at first. Why? Well, it didn't move, it didn't beep, and really didn't do anything flashy. But as we went deeper to activities, it slowly but surely became one of the most fun and useful component to us. Being more formal thought, it was mainly used to display text and values such as distance readings from the ultrasonic sensors and that one activity we did before, servo angles. And one important thing about this is the feedback it brings. It allowed us to see whether the task we are doing was functioning like how it was intended to.
With this activity, we saw and of course learned how different components work together as a single system. The ultrasonic sensor acts as the input by detecting distance, the servomotor functioned as the equator by responding to that input, and the LCD served as the output by displaying information.
But whenever these problems do occur, we troubleshoot by either re-uploading the code, rechecking connections, unplugging and reconnecting the Arduino, or reviewing our wiring.
Now for the challenges that we faced. One of them being probably the most annoying, was wiring. Honorable mention to coding. Even though the code was provided in the document, there were still times when it didn't work due to small errors or missed details. But most definitely, wiring was the most confusing and annoying, specifically when we were interpreting the diagrams.
This class very much increased our interest in robotics and engineering, although challenging and head-scratching at times. The activities and tasks were super enjoyable and rewarding. We realized that robotics is not just something seen in cartoons or media. Like, how would you see a random dude screw this and that to this? Then the machine magically works with no actual logic behind it, but a real and complex field that needs understanding and persistence. The experience helped us appreciate how much thought and effort really goes into the technology that we use daily.
All in all, this class taught us that technology is more complex than it appears. There is more than meets the eye, and that learning requires patience and effort. The knowledge and skills we gain this semester will help us approach future subjects and projects with a deeper understanding, more experience, better problem-solving skills, and collaboration. That's it for our video. Kit 2 and 8 from STEM 11 Knowledge out.